Hi, I'm Maren Leed, the Executive Director of the National Spectrum Consortium, and I'm pleased to welcome you to the Spotlight Series. This series of conversations with our membership is designed to highlight their capabilities and interests, and hopefully through that process, better foster innovation and collaboration. So today, I'm very pleased to be joined by Eric Germann, who's the Principal RF Wireless Engineer and a program manager at Alion Science and Technology. So Eric, welcome. It's great to have you.
Thanks for having me, Maren. I appreciate it. I'm excited to talk a little bit about what we're involved in here in NSC work and otherwise.
Great. So let's just dive right in. But before we do that, if you could tell me a little bit about what your day job at Alion is and what that looks like.
Yeah, so I'm a technical lead here at Alion in our Spectrum Directorate, and one of the principal things we work with is supporting the National Broadband Plan initiative that began a number of years ago, and looks at maintaining the DoD's use of spectrum to support their mission while making available wherever possible the use of spectrum for commercial interests, and looking at how sharing can be done on a temporary basis or a more long-term basis, and everything in between to make those two things coexist.
Great. So you're really, if I understand you correctly, coming at this problem from ensuring that military needs continue to be met. So the military side of the military civilian sharing construct. And also, I think, working for interoperability among military users. Is that right?
Yeah. So in the process of looking at how we can accomplish this, there's relocating users within the spectrum, compressing them down into portions of the spectrum. You end up having the twofold problem of how do I make my user community, namely the DoD, able to operate with each other still, right, as they have been for decades, and then at the same time adding this other component of now I have a commercial entity that's nearby that I want to be able to operate in the presence of, and still maintain the system performance that I need to get the mission complete.
So the NSC has been doing a lot of work on the OST 5G initiative, and Alion's been a part of that work. Can you talk a little bit about how your focus on the sharing construct is being applied for 5G?
Yeah. So we're involved on a number of fronts in the DoD's 5G initiative, and that's everything from the private 5G deployment. So in the 5G test beds that are popping up around the country. So we're partnered with a number of other companies to provide those test beds and provide them the security that's needed in those test beds through zero trust architecture and the application of that across the board. And then from a spectrum aspect, looking at how can we begin to investigate this dynamic management of the use of frequency on the federal side in the presence of this commercial operator. So it's the real world sort of proof of concept of, what can we do to make that happen through some sort of additional electromagnetic spectrum controller type solution that is taking into account the needs on the DoD side, and then working around the commercial and allowing some kind of coordination between the two, so they can both use the spectrum as needed and when needed, and then also looking at enhancing the analysis we do to explore our options, really. And we're doing that through development of some new propagation tools, namely the Viper tool, as we call it, and that is looking at being able to do full 3D propagation, which is taking propagation predictions a step further than has been done traditionally in this space. Being able to look at the full frequency span from low, mid to high millimeter wave frequencies, as it's going to be used in 5G deployments, taking into account the latest in the beam forming and array antenna array technology that's going to be utilized as well, and looking even at things like material properties in looking at in-building deployments and how does that affect my signal, and what am I able to take advantage of from a RF property, physical property standpoint to enhance my sharing. Is there a way that I can utilize certain frequency bands in specific scenarios that will allow me to achieve the sharing I need to have both things operating at the same time.
So it sounds like most of the sharing work that you're focused on is principally occurring within a kind of a cooperative sharing context. And so I just wondered about your take about how much of the technical capability that you're developing applies in a more contested operational environment as DoD really looks to up its game in that context.
Right. So the dynamic aspect of that, the dynamic frequency use that I mentioned, or dynamic spectrum allocation, that's a portion of what's going to be proven out in these test beds that is really needed to go into those contested environments. And on top of that, we're going to need the ability to not just sense the environment, learn the environment, but then adapt to it continually in real time, and actually get to the point of where we might be able to, with a relatively high amount of confidence, predict what's going to happen in that electromagnetic environment, and find those places where we can take opportunity, basically, where that environment allows us to transmit and receive as we need to, intermittently and interspersed. Also at the same time taking into account, we want to have low probability of detection and intercept. And I think machine learning and artificial intelligence enabled algorithms will allow us to do that, to collect massive amounts of data, through things like edge computing and this distributed computing environment that we're looking at now, that we have at our availability that we didn't have 10, 20 years ago. We can do a lot of this in real time. We can map the environment from a physical standpoint to get the latest attributes as we see it in the operating environment, and then also be looking at it from the EME perspective, in terms of the RF spectrum, and feed that back continually to say, okay, my environment's changing. I was able to use this portion of spectrum, for example, now for this amount of time. Well, now, I've picked up a trend here where over some span, I have these intervals in which I can operate in. So the point where you're able to sort of, to dynamically allocate those resources, much like a cellular system does, but with a lot less constraint, really, right? So it's not just, you have to take away the fact of, the spectrum's not guaranteed to me. So how do I work around that? And it's collecting as much data as you can about the environment, and then feeding that back into, okay, here's the opportunity for me to work through, what I need to in order to deploy in these contested areas.
Well, it sounds like you're right at the cutting edge of a number of different technical areas. So it sounds like really exciting work. Thanks so much for taking the time to talk to me about it today. And thanks to all of you for watching out there. If you have any questions for me or for Eric, feel free to reach out to either of us. And we look forward to seeing you again soon. Take care.
Thank you, Maren. Thanks for the opportunity.